Let us discuss factorial. Factorial of a positive integer or a non-negative integer is the product of all values from n to 1. So for example, the factorial of 3 is 6. So we just multiply 3 by all the numbers less than 3. So we have 3, 2, and 1, and the product is 6. So the factorial of 3 is 6. So we have here the factorial of n is equal to n times n minus 1 times n minus 2 until we multiply it by 1. So for example, the factorial of 4 is equal to 4 times 3 times 2 times 1. So we have 24. And then the factorial of 6, we have 720. So the recursive solution in finding the factorial, we have the factorial of n equal to n times the factorial of n minus 1. If the factorial of n is equal to 1, if n is equal to 0 or n is equal to 1. So for example here, we will find the factorial of 5. So the factorial of 5, we have 5 times the factorial of 4. And then the factorial of 4, we have 4 times the factorial of 3. Then the factorial of 3, we have 3 times the factorial of 2. And 2 is equal to 2 times factorial of 1, and 1 is equal to 1 times 1. So we have here 1. 1 times 1, 1. Then we already know the factorial of 1. So 2 times 1, we have here 2. Next, let's try to solve the factorial of 3. So 3 times 2, so 6. Then let's solve the factorial of 4. Okay, so 4 times the factorial of 3, so we have 24. Because 6 times 4 is equal to 24. Then we can now solve the factorial of 5. So 5 times the factorial of 3, we have 120. 120. Okay, so here is the implementation to calculate the factorial of n. So if n is equal to 0, we simply return to 1. Else, we make a recursive call to calculate the factorial of n minus 1, multiply it with n, and return to the output. Now, let's say time taken to calculate factorial of n is equal to t of n. It's equal to t of n. When we try to analyze time complexity of a program, we make an assumption that each simple operation costs us 1 unit of time. So if we see for n greater than 0, we first compare it with 0, which is one simple operation. So this one is cost 1 unit of time. Then we have here a multiplication operation that we perform after we get a return from factorial of n minus 1. So this is 1 unit of time. And we perform here subtraction to calculate n minus 1, which is another unit cost. So t of n is the time taken to calculate the factorial of n minus 1, which is t of n minus 1. plus 3 units of cost for the simple operation. So we have, so T of n is the time taken to calculate the factorial of n minus 1. T n minus 1 plus 3 units. We have here 1, 2, 3. 3 units of cost for the simple operation. And this is true for all integer n greater than 0. For n is equal to 0, we have t 0 is equal to 1, because we only make a comparison here and simply return. Now we have t of n equal to t of n minus 1 plus 3. Let's try to reduce this expression t of n in terms of our known value t of 0. So now t of n minus 1 can be written as t of n t of n minus 2 plus 6, and this can be further reduced to t of n minus 3 plus 9, because t of n minus 2 is nothing but t of n minus 3 plus 3. So if we have to reduce this by a generic k, then this is equal to t of n minus k plus 3k plus 3k. Now we want to express this in terms of t of 0. So in that case, we have n minus k will be equal to 0. Or k will be equal to n. So this expression would finally reduce as t of n equal to t of 0 plus 3, so we have here t of 0 is equal to 1. In this, t of 0 is equal to 1. So 1 plus, this is 3n. So 1 plus 3n. Or it can be written as 3n plus 1. So our time complexity here is the big O of n. We just simply remove the constant. So we have the big O of n. That's all.